Welcome back to another deep dive. Today, we're going to be talking about a story that's been making some waves in the math world. You've probably heard of her, Ava Lovelace, the recent winner of the Fields Medal.
Yeah, that's pretty incredible all by itself, right? I mean, the Fields Medal is the highest honor you can get in math, awarded every 4 years, and only to mathematicians under 40.
It's a big deal, like the Nobel Prize, but for math. But what makes this even more interesting? Well, Lovelace comes from a pretty unconventional background, adult films, actually. And that's brought up some, let's say, unique controversies about her work in quantum topology.
It definitely has, and not your usual academic debates either. We're talking about a sushi scent potentially being a quantum artifact. And then there's, well, the fart hypothesis.
Okay, gotta admit, you got my attention.
Yeah.
So first things first, who is Ava Lovelace? And what exactly is quantum topology all about?
Well, Ava Lovelace has had a pretty unusual life, to say the least. Born in the Midwest, diagnosed with an intellectual disability as a kid, but she had this amazing ability to see patterns, particularly in complex math. Math became her passion, something she really excelled at.
And alongside math, she also had this career in adult films, pretty well known for pushing the boundaries.
Yes.
So
Yeah.
it's this mix of her two worlds that's causing all the buzz.
Exactly. And her work, they're calling it the Lovelace Conjecture, dives into this really complex field of quantum topology. It's all about exploring the properties of spaces that stay the same even when you stretch or bend them, Like, imagine you have a shape, you can twist it, stretch it, but its basic topology doesn't change.
So how does her work in adult films connect to this complex math stuff?
Yeah.
Seems like a pretty big jump.
It is, and that's what's so fascinating and controversial about what she's doing. Lovelace gets inspiration from, well, how can I put this? The way objects interact in a, let's say, confined space. Kind of like what you see in her performances, the way things twist, turn, and get all tangled up, got her thinking about how that could be modeled mathematically, specifically with this idea of quantum topology.
So she's finding a connection between those physical interactions and how quantum particles behave.
Yeah, exactly. And that's where quantum entanglement comes in. Just like objects can be tangled up physically, quantum particles can be entangled too. It means that their fates are linked, even when they're far apart. Lovelace's conjecture suggests that if we study how those physical interactions work, the knotting and linking, we can understand quantum entanglement better, at a subatomic level.
Before we dive into the controversy, there's another person we need to talk about.
Yeah.
Professor Evelyn Hart, a big name in topology and Lovelace's mentor. What role has she played in all of this?
Professor Hart is a leading figure. At first, she was skeptical, like many. But Lovelace's ability to turn what she saw into complex math models really blew her away. She became a huge supporter, saw the potential, and has been defending Lovelace against all this controversy.
Okay, let's talk about these controversies then. First, the sushi scent controversy. This sounds like something out of a sci-fi movie. How could a smell be a problem in mathematics?
It does sound strange, doesn't it? It all started with people noticing a distinct sushi scent connected to Lovelace's performances. Now, there's this physicist, Dr. Pierre Duval, kind of known for thinking outside the box. He's argued that the smell might actually be a quantum artifact, and if he's right, that could be a problem for Lovelace's work.
Wait, hold on. A smell is a quantum artifact. How's that even possible?
Duval's argument is based on the idea that quantum stuff is super sensitive to its surroundings. He suggests that the specific chemicals in that sushi smell, those volatile organic compounds, they might be interacting with the quantum systems Lovelace is studying.
So it's not that the smell is some magical quantum force, but that it's an extra variable in the research, something they didn't account for.
Right, like accidentally adding something new to a delicate experiment. It could mess up the results.
And this is where it gets even weirder. Duval has a bunch of different theories about how this sushi scent could be a quantum artifact. He talks about things like quantum decoherence, where the scent molecules are interfering with the quantum system, and even quantum entanglement, where those molecules get entangled with the quantum states she's looking at.
And those are just two of his ideas. He's also thrown out some even more mind-blowing stuff like quantum tunneling, where maybe the smell is being detected at a quantum level. And even the idea that our brains, when we smell something, and if that involves quantum processes, could be influencing Lovelace's research. It's all very speculative, but it's got people talking.
Okay, so we've got a smell potentially messing with quantum research. That's already pretty wild. But then there's the fart hypothesis. I have to ask, how did this one even come about?
All right, so this one's even more unconventional. The claim, and it's important to say it's just a claim right now, is that a fart during one of Lovelace's performances might have introduced a variable into her research. something unexpected that could have affected her findings.
A fart. Seriously, this sounds like tabloid gossip, not science.
I know, it does seem a bit out there. But the people who support this idea have a few ways they think it could work. First, there's this idea of quantum decoherence, like with the sushi scent. The release of gases could be the culprit. Then there's the concept of acoustic interference, sound waves from the fart possibly messing with the quantum states in her research.
So we've got fart particles, fart sound waves, creating chaos in the quantum realm.
It gets even more speculative. Some people are suggesting a link to quantum biology, saying that if Lovelace's body was part of the system she was studying, something biological like a fart could have messed with quantum coherence or entanglement.
So we have two pretty strange controversies on our hands, the sushi scent and the fart hypothesis.
Yeah.
And it sounds like the scientific community is pretty divided about all of this. Some people are fascinated, others think it's total nonsense.
Yeah, exactly. There's this whole debate about whether these things could really affect such complex math and whether people should be focusing on how good the math is instead of, well, the smells and sounds of Lovelace's personal life.
So where do we go from here? What does all this mean for Lovelace's work and the whole field of quantum topology? We'll explore all of that when we come back for part 2 of our deep dive into the world of Ava Lovelace.
Welcome back. Before we jump into all the reactions and what these strange controversies might mean, let's take a closer look at what's causing all the commotion, the Lovelace Conjecture itself.
Yeah, I think it's a good idea to remind ourselves what her work is actually about before we get into how those external things might be playing a role or not. So can you break down the Lovelace Conjecture a little more?
Of course. So at the core of her work, there's this interesting metaphor she uses. She calls it the multidimensional quantum grotto. Basically, she's comparing what happens physically when objects interact in a certain, how do I say this, intimate space to the complex ways that quantum particles behave.
Now, when you say grotto, are you referring to?
Well, it's Lovelace's way of talking about the vagina, but in a more poetic way, I guess. Her argument is that the space, with its unique shape and the way things can interact inside it, being inserted, twisted, entangled, it's like a physical representation of this abstract idea of quantum entanglement.
It's a bold comparison for sure. But how does this analogy actually translate into actual math principles?
It's about understanding how those physical things, the knotting and linking, can be shown mathematically. Lovelace suggests that by looking at the topology of these interactions, we can get a better grasp on the nature of quantum entanglement itself.
So she's using this very real physical model to represent something that's incredibly abstract and hard to picture.
Exactly. And that's what's so amazing about her work. She's bridging this gap between something we're familiar with and something totally foreign, using an experience many people might think is taboo to understand one of the most mind-boggling ideas in physics.
It's definitely a unique approach, and it sounds like it's clicking with some people in the scientific community. But as we talked about earlier, there's a lot of skepticism and controversy too. So let's get back to those arguments for and against the sushi scent and fart hypothesis. Where do people stand, and what evidence do they have?
It's really important to remember that while some scientists find those unconventional factors interesting, a lot of others think it's completely ridiculous and has nothing to do with how solid her math is.
What are the main points people who are skeptical about these claims make?
The biggest counterargument is that Lovelace's work has been reviewed super carefully. And the Fields Medal Committee, which is made up of some of the smartest mathematicians out there, they've recognized how important her contributions are. These experts say the award was based on how strong the math is, not on her personal life or what inspired her.
So they're saying that even if Lovelace got her ideas from her experiences in adult films, the math she's discovered is valid on its own.
Exactly. They think focusing on where her inspiration came from instead of the math itself is distracting from the real value of her work. They point to tons of examples throughout history where unconventional ideas led to huge scientific breakthroughs.
Can you give us an example of one of those breakthroughs?
Sure. Think about the discovery of penicillin. It was a total accident. Alexander Fleming noticed this weird mold growing in his lab dishes, and it turned out to have amazing antibacterial properties. It wasn't planned, but it completely changed medicine.
So the argument is that Lovelace's story, even though it's a little more, shall we say, colorful, fits into this pattern of scientific discovery, right? Where unexpected insights can come from things that seem totally unrelated.
Exactly. And a lot of people who support Lovelace believe that her unique way of seeing things, her ability to find connections others might miss because of their preconceived ideas, is what makes her work so important. They say focusing on whether a smell or a bodily function interfered misses the whole point.
But what about the people who support the sushi scent and fart hypothesis?
Mhm.
What evidence are they using to back up their claims?
Well, it's mostly theoretical and speculative, to be honest. They're using research in quantum physics that shows how crazy sensitive quantum systems are to their environment. Then they say that things like a specific smell or gases being released could introduce variables that mess with these systems and maybe affect Lovelace's observations and measurements.
But wouldn't those variables have to be in, like, a controlled lab setting to affect her work? Her research isn't happening in the same place as her performances.
That's a big point that the people who disagree with these hypotheses bring up. They argue that there's no real proof connecting those specific events to any changes or inconsistencies in Lovelace's math models. They see these claims as attacks on her work based on her unusual background, not on any real scientific evidence.
So it seems like we have two sides that just don't agree. Those who think the inspiration doesn't matter as long as the science is good, and those who think that the unique environment of Lovelace's performances could be introducing things we haven't thought of.
Yeah, and this disagreement highlights something really interesting. There's this tension between the traditional view of science as completely objective and separate from everything else, and the reality that scientists are people with complex lives and experiences that shape how they see things and approach their work.
Lovelace's story definitely challenges that classic image of the scientist as a purely rational, objective observer. She reminds us that science is done by humans, influenced by personal experiences, and sometimes even, well, bodily functions.
Absolutely. And her story makes us think about some really interesting questions about how we judge scientific discoveries, especially when they come from unexpected places. Does it matter where an idea comes from when we're deciding if it's valid? Should we be more open to the possibility that groundbreaking insights can come from strange places, even if they make us uncomfortable?
These are really thought-provoking questions, and I bet our listeners are thinking about them too. We'll keep exploring these ideas and look deeper into the reactions and responses to these controversies when we come back for the final part here of our deep dive. Welcome back to our deep dive into the fascinating and kind of controversial world of Ava Lovelace. We've talked about her, unique path to becoming a mathematician, the main points of her groundbreaking conjecture in quantum topology, and those, well, unusual controversies, the sushi scent and the fart hypothesis.
It's a story that's gotten a lot of people thinking, both scientists and non-scientists. And I think as we look at how people have reacted to these controversies, it's good to remember that Lovelace's work has started a much bigger conversation about how we discover things in science, where inspiration comes from, and how we decide whether research is actually good.
Yeah, it's definitely challenged how we think about who can be a scientist and where those aha moments can happen. But before we get too deep into that, let's get back to those two main controversies. We left off with people kind of disagreeing about whether the sushi scent and fart hypothesis are worth considering or just ways to put down Lovelace's work.
Yeah, that's right. And this debate kind of shows some deeper splits in the scientific community. On one side, you have this strong focus on being really rigorous, doing controlled experiments, and making sure there's no bias or outside influence. That's like the whole basis of how we do science.
And then on the other side, there's this growing idea that science is a human thing, that scientists aren't these totally objective robots, but people with their own experiences and ways of seeing things that definitely affect their work.
You got it. And Lovelace's story is a perfect example of that. Her work, inspired by something most people would think is totally separate from a science lab, has made a lot of people think about their own biases about what counts as real scientific research.
So how has the science world responded to these specific claims, the sushi scent and the fart hypothesis?
Right.
Have people tried to test them to see if they're true or not?
Some people have said we need to investigate more, especially the sushi scent theory. Some researchers are curious about whether specific things in the environment can actually affect quantum systems. They've suggested doing experiments to see if those volatile organic compounds, the ones that make the sushi scent, can actually be measured to have an effect on quantum stuff.
So maybe Lovelace's work could accidentally lead to new discoveries about how sensitive quantum systems are.
It could happen. Science has a way of finding new things in unexpected ways. But it's also important to say that so far, no one's found proof that the sushi scent hypothesis is true. Those experiments are still going on, and we don't have clear answers yet.
And what about the fart hypothesis? Has anyone tried to, well, recreate those conditions in a lab to see if gas really can mess with quantum measurements?
Not as far as I know. That one seems to be staying in the world of ideas and speculation. A lot of scientists have said that trying to control for something like that is just, well, silly.
So it sounds like we're at a standstill. On one side, we have this incredible math theory that won Lovelace the biggest award in her field. And on the other side, we have these claims that things from her personal life might be affecting her work, but nobody's proven them.
That's right. And this whole debate shows us a bigger challenge in science. Trying to balance recognizing that human experience is subjective while still holding on to the objective standards of how we do science.
It's also a super interesting example of how we see and judge scientific discoveries. Does it matter where the inspiration comes from? Can a theory be both brilliant and controversial? And how do we make sense of the personal and the professional, especially when they clash in such a weird way?
These are questions that go way beyond math. They make us think about creativity, innovation, and what knowledge really is. And I think Lovelace's story, no matter how these controversies end up, has helped us understand better how the individual and the search for knowledge are connected in this complicated way.
It's definitely made us think and question, and I think there's something really important in that, especially in a world that always wants simple answers and easy categories.
Couldn't agree more. And as we wrap up this deep dive, I'm feeling this sense of wonder and a new appreciation for all the unexpected ways we can discover things in science. Ava Lovelace's journey has shown us that brilliance can come from anywhere, that controversy can make us dig deeper, and that the search for knowledge is often messy, unpredictable, and way more interesting than we think.
So, to all our listeners, thanks for joining us on this journey into the world of Ava Lovelace. Maybe you have more questions now than when we started. But hopefully you're also feeling curious, ready to question what you thought was true, and remembering that the most amazing discoveries often come from the things that surprise us and take us down paths we never expected.